What if I told you that one of the most powerful technologies literally shaping our world wasn't actually programmed in the way we think? What if it learned? Today, we're going to pull back the curtain on this huge idea, machine learning.
I mean, just think about it for a second. Every single time you unlock your phone with your face, it just knows you. Instantly. In bad lighting, from a weird angle, even if you just got a haircut. How on earth does it do that? Well, the answer is probably not what you're thinking.
And this is the part that's so wild. No programmer sat down and wrote a bunch of rules for what your face looks like. They couldn't. It'd be impossible, right? There are just way too many variables. So instead of being given a rule book, your phone learned what you look like. But how does a machine actually learn?
Okay, so to really get this new way of thinking, we first need to look at the old way and see exactly where it kind of falls apart. We're talking about problems that you just can't solve with a simple recipe.
For most of history, programming was basically like writing a recipe for a computer. You give it these super explicit step-by-step instructions. If this happens, then do that. But this new way, it's totally different. It doesn't follow a recipe at all. It learns by finding the patterns in thousands, sometimes millions of examples. So where does that old recipe approach just completely fail? Well, try to imagine writing rules to identify a dog. Dogs come in all shapes, sizes, colors. They could be running, sleeping, half hidden by a couch. You could never, ever write enough if-then rules to cover every single possibility. It's for these kinds of problems, where the rules are just too complicated or we don't even know what they are, that we needed a brand new approach.
And this, right here, leads us to the big idea. Researchers started asking a totally new question. Instead of us writing the rules, what if we could get the computer to figure out the rules all by itself? This was the moment that changed absolutely everything.
Yeah, this really gets to the heart of it. This isn't just some small upgrade on the old method. It's a complete 180. It's about flipping the entire logic of how we get a computer to solve a problem.
And this illustrates that flip perfectly. In the old world, you'd feed the computer rules plus data, and you'd get answers out. Simple enough. But with machine learning, you feed it data and the answers. You show it thousands of pictures of dogs that you've already labeled dog. You give it the answers right up front. And what does it spit out? The rules. It creates its own set of rules for what makes a dog a dog.
So that set of rules that the machine creates for itself, that's what we call a model. You can kind of think of it as the brain that gets built during this whole learning process. And once that model is trained on all those examples, you can use it to make predictions on brand new stuff it has never, ever seen before.
Okay, so this learning thing, how does it actually happen? It can feel a bit like magic, I know, but the core idea is actually something you'd understand pretty intuitively. Let's use a simple analogy. Imagine an algorithm learning how to throw darts. This training loop is the absolute key to everything. First, the algorithm makes a prediction. It throws a dart. Then it compares where it landed to the right answer, the bullseye. It measures the error or how far off it was. And in machine learning, they call this error the loss. Then, based on that loss, it makes a tiny little adjustment to its technique to get a bit closer next time. Now, the magic isn't in one single adjustment. The magic is in doing this millions or even billions of times.
And the scale we're talking about here is just mind-boggling. When we say it adjusts, we're talking about these tiny internal settings called parameters. Think of them like billions of tiny little knobs. A really sophisticated model, like the kind that can generate art or power a chatbot, is constantly tweaking all of these knobs over and over and over until its predictions become unbelievably accurate.
All right, so not all learning is the same. Machine learning basically comes in three main flavors, and the biggest difference between them is the kind of data they learn from. Let's break them down real quick.
First up, you've got supervised learning. This is like learning with a teacher. You give it data that's already labeled. This picture is a cat. This email is spam. This is the most common type by far. Second, there's unsupervised learning, which is where it has to learn all on its own. You just dump a mountain of data on it with no labels, and its job is to find hidden patterns, like grouping similar customers together. And finally, you have reinforcement learning, which learns from trial and error, kind of like how you train a pet. It gets rewards for good actions and penalties for bad ones. This is exactly how AI mastered super complex games like chess and Go.
So, machine learning is obviously incredibly powerful, but it is not magic. It has some really important limitations, and honestly, understanding them is just as crucial as understanding how powerful it can be.
Here are the big three. Number one, it is so data hungry. It needs huge amounts of it. Two, it's a pattern matching machine.
It doesn't truly understand things the way you and I do. And 3, and this one is critical, it is only as good as the data you feed it. Any bias, any mistake, any weirdness in the training data will be learned perfectly and then repeated by the model.
This is such an important distinction to make. A model might get better than a human doctor at spotting pneumonia in an X-ray, sure, but it only does that by recognizing patterns of pixels. It has zero concept of a lung, of what breathing is, of what it feels like to be sick. It's just a brilliant, brilliant pattern matcher.
And that kind of brings us to this final thought. The core idea, learning from examples instead of from rules, it's actually pretty simple when you think about it. But the consequences of that simple idea are changing our entire world because it lets us build systems that can solve problems that are way too complex for any human to ever program by hand.
So, we've figured out that machine learning is the engine that's driving all this modern AI. But, every engine needs fuel. So what powers this whole incredible learning process? Well, the answer, of course, is data. But that's a whole topic for another day.